All right, now we got some fun ones. We are told that A are the numbers 2, 4, 6, 8, 10, 12. B are multiples of 3 from 3 to 18. And C are the first 5 counting numbers. But what I don't tell you, and I should totally tell you, let's say the universal set is a set of all x such that x is between 1 and 20. And we'll say natural. So if you need to, write it out. I won't write them all out here. Oh, comma, comma, 1920. Okay. So part A, we're going to union, which means put together sets A and B. So what are the elements if you were to put them both in one box? Typically, I like to write them in numerical order. You don't have to, but remember, if there's an element in both, you only need to write it once. So, for instance, the number 2 comes from set A, the number 3 comes from set B, 4 comes from A, they both happen to have 6, so just write it once. 8 comes from A, 9 comes from B, 10 comes from A, they both have 12, just write it once. 15 and 18 come from B. So again, just put it together. A union C, same idea. We're going to put sets A and C together in the same box. Well, C contributes the first 5 natural numbers. Oh my gosh. Well, guess what? It doesn't matter the order in which you write them. So I don't have to fix that mistake because it's not a mistake. It's fine. And then on top of that, A also contributes 6, 8, 10, and 12. I'm going to put those on another line here. 10, 12. Okay, but in part C, we need to say what A and C have in common. A and C only have in common 2 and 4. So remember, the U symbol means union, put them together. The intersect symbol means and, only what they have in common. How about part D? What do sets B and C have in common? They only have in common 3. That's it. That's all B and C have in common. E, C intersect the empty set. The empty set is the set that contains no elements. So if there is a set that contains no elements, what does it have in common with any other set? Nothing. In fact, anytime you intersect with the empty set, it works like multiplying by 0. You always get back 0. Anytime you intersect with the empty set, you always get the empty set. On the flip side, in part F, we're going to union with the empty set. So the set B contains multiples of 3 from 3 to 18 inclusive. And the empty set contributes nothing to that. So if we were to put both in the same box, we would get back the set B. So when you union with the empty set, like in part F, you always get back the original set. It's like adding 0. Adding 0 to any number gives you back that same number. Okay. Part G has a complement in it. That's what the little prime means. And notice part G relates to part B. It just happens to be the complement of B. So if the universal set is the natural numbers 1 through 20, and in part B we found the union of A and C is 1, 2, 3, 4, 5, 6, 8, 10, 12, we're going to take those numbers out of the universal set, and that would leave us with 7, 9, 11, and then 13 up to 20. 19, 20. Oh, my braces, so bad. Part H. B intersects C, we found in part D, just to be the lonely number 3. And now we're going to complement it, which means take 3 out of the universal set. What would we be left with? Everything but 3. So you can say 1, 2, 4, 5, 6. If a pattern's established, we see 4, 5, 6. I'm just going to put a 7 for safe measure. Nothing's wrong with saying ... at that point, and then finishing it off 19, 20. So we told the viewer, hey, there's no 3, but we're going up to 20 anyways. That's totally fine. Part I, we're going to union A and B, that's in parentheses, which we already did in part A. And we're going to take that answer in part A and intersect it with C. So looking at our answer in part A, what does it also have in common with C? You'll notice it just has in common 2, 3, 4.